Hello there, and welcome to this gentle journey through one of the most beautiful mysteries in all of science. Tonight, we're exploring a principle that whispers a profound truth about the universe. There are some things we simply cannot know, no matter how hard we try, no matter how clever our instruments become. This isn't a limitation of our technology or our minds, but rather a fundamental feature woven into the very fabric of reality itself. Where in the world are you listening from right now? And as you settle in, perhaps with a warm cup of tea or wrapped in your favorite blanket, take a moment to consider this. You exist in a universe that guards some of its secrets not out of stubbornness, but out of necessity. If you find this exploration soothing, intriguing, or simply a peaceful way to unwind, I'd be ever so grateful if you gave this a like. It helps this little corner of contemplation reach others who might need a moment of wonder in their day. Now, I do hope this isn't so fascinating that it keeps you awake, but if it does, well, at least you'll drift off having pondered one of the most elegant puzzles the cosmos has to offer. So slow your thoughts, let your breathing settle, and let's begin our gentle voyage into the heart of uncertainty itself. Imagine, if you will, trying to photograph a hummingbird in flight. The moment you snap the picture, you capture exactly where it was at that instant, frozen in time and space. But here's the curious thing. In that very act of capturing its precise location, you've lost all information about how fast it was moving or where it was headed. The photograph shows you position perfectly, but motion has vanished completely. Now imagine trying a different approach. You decide to film the hummingbird instead, focusing on capturing its speed and direction as it darts between flowers. You can measure its velocity beautifully, but now, in any single frame, the bird is nothing but a blur. You know how fast it's moving, but you've lost the ability to say exactly where it is at any given moment. This delightful paradox isn't just about photography or hummingbirds, it's a gentle metaphor for one of the most profound discoveries in all of physics, Heisenberg's uncertainty principle. At the smallest scales of reality, in the quantum realm where atoms and particles dance their mysterious ballet, this trade-off between knowing position and knowing motion isn't just a practical limitation. It's a fundamental law of nature. Werner Heisenberg, a young German physicist working in the 1920s, discovered that when we try to measure certain pairs of properties of a particle simultaneously, we run into an absolute wall. Not a wall built by the limitations of our instruments, but a wall built into the architecture of reality itself. The more precisely we try to determine where a particle is, the less precisely we can know how fast it's moving. And conversely, the more precisely we measure its speed, the fuzzier its location becomes. This isn't because our measuring devices are clumsy or inadequate. It's because the very act of observation at the quantum level is like trying to feel your way around a dark room with a flashlight that's far too bright. To see where something is, you have to shine light on it. But at the quantum scale, even a single photon of light carries enough energy to give the particle a little push, changing its motion in unpredictable ways. Picture trying to measure the position of a soap bubble floating in the air, but the only tool you have is a tennis ball. Every time you gently toss the tennis ball to touch the bubble and see where it is, you inevitably pop it or send it flying in a random direction. The gentler you try to be, the less information you get about where it was. The more precisely you try to locate it, the more you disturb its delicate motion. But here's where it gets truly beautiful, and perhaps a little unsettling. Heisenberg showed us that this isn't just about our measuring techniques, it's about the nature of reality itself. Even if we never try to measure a particle, even if we leave it completely alone, it still doesn't have both a definite position and a definite velocity at the same time. It's not that we don't know these values, it's that they don't exist in the way we normally think about existence. At the quantum level, particles exist in a state of fundamental uncertainty, a kind of shimmering possibility where they're neither here nor there, neither fast nor slow, until the moment we decide to look. It's as if reality itself is written in pencil rather than ink, with certain details remaining deliberately smudged until we force them into focus. This principle extends far beyond simple position and momentum. There are many pairs of properties that can't be measured simultaneously with perfect precision. Energy and time form another such pair. If you try to measure exactly how much energy a particle has at a precise moment, you lose the ability to say exactly when it had that energy. The universe, it seems, keeps its books balanced by ensuring that total certainty about some things always comes at the cost of uncertainty about others. The implications ripple outward like gentle waves on a still pond. In the quantum world, particles can borrow energy from the vacuum of space itself, popping into existence for the briefest of moments before disappearing again, like cosmic fireflies blinking in and out of reality. These virtual particles, as they're called, exist in the gaps of our knowledge, in the spaces that uncertainty creates. It's worth pausing here to consider what this means for our everyday experience. You sitting there now listening to these words are made of countless atoms, each one obeying Heisenberg's principle. Every electron in your body, every photon of light reaching your eyes, every sound wave entering your ears is subject to this fundamental uncertainty. Yet somehow from this quantum fuzziness emerges the solid, predictable world of your daily experience. This is one of the most beautiful mysteries in science. How does a universe built on uncertainty give rise to the apparent certainty of our macroscopic world? It's rather like asking how a symphony emerges from the individual, uncertain notes of countless musicians, each playing their part in a vast, improvised composition. The answer lies partly in numbers. You contain approximately 7 octillion atoms. That's a 7 followed by 27 zeros. When you have that many uncertain particles all behaving according to the same probabilistic rules, their individual uncertainties tend to average out, creating the stable, predictable matter we experience. It's rather like flipping a coin. Flip it once and you can't predict the outcome. Flip it 1 billion times and you can predict with great confidence that about half will be heads. But this classical emergence from quantum uncertainty doesn't eliminate the underlying mystery. It simply pushes it to a different level. The uncertainty isn't destroyed, it's transformed, woven into the very fabric of how things change and evolve over time. Consider the act of breathing. Each breath you take involves countless quantum events. Electrons jumping between energy levels, molecules vibrating in precisely uncertain ways, chemical bonds forming and breaking according to probabilistic rules. Yet from this microscopic dance of uncertainty emerges the reliable, life-sustaining rhythm of respiration. You don't need to worry about your next breath being governed by quantum uncertainty. The statistics of large numbers ensure that your lungs will work predictably. But zoom in far enough and the uncertainty is always there, humming quietly beneath the surface of experience. Every chemical reaction in your body, every thought passing through your mind, every sensation you feel emerges from quantum processes that are, at their core, fundamentally uncertain. This brings us to a profound philosophical question. If uncertainty is built into the foundation of reality, what does this mean for our understanding of knowledge itself? For centuries, science has been driven by the dream of complete knowledge, the idea that with enough time, enough precision, enough cleverness, we could in principle know everything there is to know about the universe. Heisenberg's principle suggests that this dream, beautiful as it is impossible in principle. There are aspects of reality that will forever remain beyond our complete knowledge, not because we're not smart enough or because our instruments aren't precise enough, but because complete knowledge of certain things is prohibited by the fundamental structure of the universe. This isn't a cause for despair, but rather for wonder. The universe has built-in mystery, permanent room for surprise, eternal space for the unknown. In a strange way, uncertainty guarantees that reality will always be more interesting than any complete description of it could ever be. Some physicists and philosophers have suggested that uncertainty might be the price we pay for free will, for creativity, for the genuine novelty that seems to emerge in the world. If everything were completely determined, if every property of every particle were fixed and knowable, would there be room for consciousness, for choice, for the unexpected beauty of a sunset or the surprising turn of a conversation. Perhaps uncertainty isn't a bug in the cosmic code, but a feature. Perhaps the universe's refusal to be completely known is what allows it to be genuinely alive, truly creative, perpetually surprising. In hiding some of its secrets, reality ensures that there will always be more to discover, more to wonder about, more to explore. As you lie there now, perhaps feeling the gentle pull of sleep, consider this. You are part of an uncertain universe, a cosmos that keeps some of its deepest secrets not out of stubbornness, but out of wisdom. Every atom in your body participates in this cosmic dance of uncertainty, this fundamental refusal to be completely pinned down and catalogued. And perhaps that's exactly as it should be. In a universe of complete certainty, there would be no room for growth, no space for wonder, no possibility of genuine surprise. The uncertainty that Heisenberg discovered isn't a limitation of our knowledge, it's the source of possibility itself. So as you drift towards sleep, carried by the gentle rhythm of your breath, remember that you exist in a universe that has chosen mystery over complete revelation, possibility over rigid determination. You are part of a cosmos that will always have more secrets to share, more wonders to reveal, more beautiful uncertainties to explore. The universe, it seems, prefers to keep us guessing. Now you might be wondering, how does all this theoretical physics actually connect to your daily life? How does uncertainty at the quantum level ripple outward into the world we can see and touch? Well, that's where things get beautifully complex, because the universe has this remarkable way of weaving mystery into the very fabric of everything around us. You see, Heisenberg's uncertainty principle isn't just some abstract concept locked away in laboratory equipment or theoretical equations. It's actually the invisible choreographer behind many of the phenomena that make our world possible. Take something as simple as the stability of atoms themselves. If electrons could have perfectly defined positions and velocities, they would spiral into the nucleus, and matter as we know it would collapse. But uncertainty saves the day. The electron's fuzzy, probabilistic existence keeps it dancing around the nucleus in a quantum waltz that prevents atomic collapse. This quantum uncertainty also powers the sun that warms your face and lights your day. Nuclear fusion, the process that makes stars shine, relies on quantum tunneling, a phenomenon that emerges directly from the uncertainty principle. Particles can tunnel through energy barriers they classically shouldn't be able to cross, precisely because their positions and energies are fundamentally uncertain. Without this quantum uncertainty, the sun would be a cold, dark sphere, and we wouldn't be here to ponder these mysteries. But let's bring this even closer to home. The very device you're listening to this on, whether it's a smartphone, tablet, or computer, exists because engineers learned to harness quantum uncertainty. Semiconductors, the foundation of all modern electronics, work because electrons can exist in uncertain states between energy levels. The transistors processing these words right now are quantum mechanical devices, switching between states in a dance of probability and uncertainty. Even more remarkably, your ability to see anything at all depends on quantum uncertainty. When light hits your retina, it triggers a cascade of quantum events. Photons, those fundamental particles of light, exhibit wave-particle duality, another manifestation of quantum uncertainty. They behave as both waves and particles, depending on how you observe them. This isn't just academic curiosity, it's the mechanism that allows your eyes to capture the world and your brain to construct the rich visual experience you call reality. And here's something that might surprise you. The uncertainty principle plays a role in the very structure of empty space itself. What we call vacuum isn't actually empty. It's buzzing with quantum fluctuations, virtual particles popping in and out of existence in tiny fractions of time. These fluctuations arise directly from the uncertainty principle, because energy and time are subject to their own uncertainty relationship. Space itself is uncertain, constantly shimmering with possibilities. This quantum foam, as physicists sometimes call it, has measurable effects. It creates a tiny force called the Casimir effect. where two metal plates placed very close together in a vacuum will be pushed toward each other by the quantum fluctuations of empty space. The universe's uncertainty literally generates forces from nothingness. But perhaps most fascinating is how quantum uncertainty might be connected to consciousness itself. While the science is still developing and hotly debated, some researchers suggest that the brain's neural networks might operate partially through quantum processes. The microtubules in neurons, the intricate structures that help maintain cell shape, might be quantum processing units using uncertainty and superposition to enable the rich, complex phenomenon we call consciousness. Now, this doesn't mean your thoughts are directly causing quantum collapse or that you can change reality with your mind in some mystical sense, but it does suggest that the very experience of being aware, of having thoughts and feelings, might emerge from the same uncertain quantum processes that govern the smallest scales of reality. Your consciousness might be uncertainty becoming aware of itself. This brings us to something profound about knowledge and understanding. The uncertainty principle teaches us that the universe isn't just complicated because we haven't built good enough instruments or developed clever enough theories. It's inherently uncertain, fundamentally mysterious. And rather than being a limitation, this uncertainty might be the source of everything beautiful and complex in our world. Think about creativity for a moment. Where do new ideas come from? They seem to emerge from somewhere uncertain, somewhere between what we know and what we don't know. The space of possibility, the realm of potential, is where innovation lives. If everything were perfectly determined and predictable, there would be no room for the unexpected insights that drive art, science, and human progress. The uncertainty principle suggests that novelty and surprise are built into the very foundations of reality. The universe is constantly generating new possibilities, new configurations, new ways of being. Every quantum measurement creates a unique outcome that has never existed before and will never exist again in exactly the same way. Reality is constantly creating itself anew. This has profound implications for how we understand our place in the cosmos. We're not just observers of a predetermined universe, watching a cosmic movie that was written billions of years ago. We're participants in an ongoing creation, where uncertainty and possibility are constantly flowering into new forms of existence. Even our scientific understanding participates in this creative process. Each experiment, each measurement, each observation brings new information into being. The act of knowing changes what is known. The universe becomes more definite, more real through our interactions with it. Knowledge isn't just discovery, it's a form of creation, and this returns us to the fundamental question of what it means to know something. The uncertainty principle suggests that complete knowledge might not just be practically impossible, but conceptually meaningless. The universe might be more like a living conversation than a fixed text. Each question we ask changes the possible answers. To each answer we receive opens new questions. This doesn't make science less valuable or knowledge less important. If anything, it makes them more precious. In a world of infinite possibility, every piece of understanding we gain is a small miracle, a temporary crystallization of meaning from the flux of uncertainty. Our knowledge is like islands of clarity in an ocean of mystery, and the mystery makes the clarity more beautiful, not less. So as you go about your day, remember that you're swimming in uncertainty. Every breath you take involves trillions of quantum events, each one a small roll of the cosmic dice. The light streaming through your window carries the signature of quantum uncertainty. The thoughts in your mind might emerge from the same probabilistic processes that govern atoms and stars, and perhaps that's the most wonderful thing of all. We're not separate from the mystery, we're part of it. The universe's uncertainty lives in us, thinks through us, wonders about itself through our curiosity. We are the cosmos becoming conscious of its own beautiful, uncertain nature. In the end, Heisenberg's uncertainty principle isn't just about the limits of measurement or the behavior of subatomic particles. It's about the fundamental creativity of existence itself. It's about a universe that prefers questions to answers, possibilities to certainties, and wonder to the illusion of complete understanding. And maybe that's exactly as it should be. Now let's dive deeper into what makes uncertainty so fundamentally different from simple ignorance or measurement error. You see, there's a crucial distinction here that often gets overlooked in casual discussions about quantum mechanics. When we say we can't know both the position and momentum of a particle precisely, we're not just admitting the limits of our instruments or confessing that we haven't been clever enough yet to figure out the right technique. This isn't like trying to measure the temperature of a cup of tea with a broken thermometer, where the problem lies with our tools. The uncertainty principle reveals something far more profound and frankly rather unsettling about the nature of reality itself. The particle genuinely doesn't have both a definite position and a definite momentum simultaneously. It's not that these properties are hidden from us, waiting to be discovered with better equipment. They simply don't exist in the way we intuitively expect them to. Think of it this way. When you're not looking at the moon, you probably assume it's still there, hanging in the sky with a definite position and following a predictable path. That's classical thinking, and it works beautifully for moons and tennis balls and all the everyday objects we encounter. But in the quantum realm, particles exist in what physicists call superposition states, where they're genuinely spread out across multiple possibilities until something forces them to choose. This leads us to one of the most famous thought experiments in physics, though we won't get tangled up in the details. The key insight is that quantum objects exist in a kind of fuzzy, probabilistic state until they interact with something else. It's as if reality itself is constantly improvising, making decisions on the fly about which possibility to manifest. But here's where it gets really interesting. This fundamental uncertainty isn't a bug in the system, it's a feature. Without it, the universe as we know it simply couldn't exist. Let's consider the hydrogen atom, the simplest atom in the universe, consisting of just one proton and one electron. In classical physics, that electron should spiral into the proton almost immediately, radiating energy as it falls inward. The atom should collapse in less than a trillionth of a second, yet here we are, made of atoms that have been stable for billions of years. What saves us from this catastrophic collapse? The uncertainty principle. Because we can't pinpoint exactly where the electron is, it exists in a cloud of probability around the nucleus. This quantum fuzziness provides a kind of buffer, a fundamental restlessness that keeps the electron from settling into the proton's embrace. The same principle governs the nuclear reactions that power the sun. Deep in the solar core, hydrogen nuclei are trying to fuse together to form helium, but they face an enormous energy barrier. Classically, they shouldn't have enough energy to overcome this barrier. Yet fusion happens anyway thanks to quantum tunneling, another consequence of the uncertainty principle. Particles can borrow energy from the vacuum itself, briefly violating what we think of as conservation of energy, as long as they pay it back quickly enough. This borrowing and lending of energy happens everywhere, all the time. The vacuum of space, which we might imagine as perfectly empty, is actually seething with quantum activity. Virtual particles pop into existence, dance briefly with their partners, and then annihilate back into nothingness. These quantum fluctuations are so fundamental that they've left their fingerprints on the cosmic microwave background radiation, the afterglow of the Big Bang itself. The uncertainty principle even influences the technology you're using right now. Every electronic device relies on the behavior of electrons in semiconductors, and that behavior is governed by quantum mechanics. The tunneling effect allows electrons to pass through barriers they classically shouldn't be able to cross, enabling the miniaturization of computer chips. Without quantum uncertainty, your smartphone would be impossible. But perhaps the most profound implication is what this tells us about the nature of information itself. The uncertainty principle suggests that there are fundamental limits to how much information can be encoded in any given region of space. This connects to deep questions about black holes, the holographic principle, and whether our three-dimensional reality might actually be a projection from a two-dimensional surface. Some physicists go even further, suggesting that uncertainty might be the universe's way of preventing paradoxes. If we could know everything about a quantum system with perfect precision, we might be able to predict the future with absolute certainty. But such perfect predictability could lead to logical contradictions, like the grandfather paradox in time travel stories. Uncertainty preserves the universe's ability to surprise itself. There's also a beautiful connection between uncertainty and creativity. In a perfectly deterministic universe where every future moment is completely determined by the past, there would be no room for genuine novelty. But quantum uncertainty introduces an element of fundamental randomness that allows for truly new possibilities to emerge. Some researchers even speculate that consciousness itself might depend on quantum processes in the brain, though this remains highly controversial. The uncertainty principle also has implications for how we think about measurement and observation. Every time we try to measure a quantum system, we inevitably disturb it. The act of observation changes the system being observed, creating what physicists call the measurement problem. This isn't just a technical issue, it's a fundamental puzzle about the relationship between the observer and the observed. This leads to some rather mind-bending questions. If quantum systems exist in superposition until they're measured, what counts as a measurement? Does it require a conscious observer, or will any interaction do? Some interpretations of quantum mechanics suggest that consciousness plays a special role in collapsing the wave function, while others argue that any interaction with the environment is sufficient. The uncertainty principle also connects to the concept of complementarity, introduced by Niels Bohr. This idea suggests that quantum objects can exhibit seemingly contradictory properties, like being both a wave and a particle, but never simultaneously. The property we observe depends on how we choose to look. It's as if reality has multiple faces, and we can only see one at a time. This complementarity extends beyond physics into philosophy and even psychology. Perhaps our own thoughts and emotions operate according to similar principles, existing in superposition states until the moment we examine them. The act of introspection might collapse our fuzzy feelings into definite states, just as measuring a quantum system forces it to choose a specific outcome. The uncertainty principle reminds us that the universe is far stranger and more wonderful than our everyday experience suggests. It's a place where particles can be in multiple places at once, where empty space teems with activity, and where the very act of looking changes what we see. It's a universe that preserves mystery at its core, ensuring that there will always be more to discover, more to wonder about, more to explore. In many ways, the uncertainty principle is a gift. It prevents the universe from being a cold, mechanical clockwork where everything is predetermined. Instead, it gives us a cosmos that's alive with possibility, where chance and necessity dance together in an eternal improvisation. It's a universe that can surprise us, delight us, and remind us that despite all our scientific progress, we're still barely scratching the surface of reality's deepest mysteries. And perhaps that's exactly as it should be. A universe without uncertainty would be a universe without wonder, without the delicious tension between the known and the unknown that drives all scientific inquiry. But here's where things get truly fascinating, and where the uncertainty principle reveals perhaps its most profound implications for human existence. We've seen how quantum uncertainty creates the very foundation of reality. But what does this mean for us as conscious beings trying to make sense of our place in the universe? You see, consciousness itself might be intimately connected to quantum uncertainty. Think about it for a moment. Every thought you have, every decision you make, every creative spark that ignites in your mind emerges from the intricate dance of billions of neurons. And at the quantum level, these neural processes are governed by the same uncertainty that shapes atoms and particles. Some scientists propose that consciousness doesn't arise despite quantum uncertainty, but because of it. The brain, they suggest, might be a kind of quantum computer, using the fundamental fuzziness of reality to generate the rich, unpredictable inner world of thoughts, emotions, and experiences that we call consciousness. It's as if the universe's preference for possibility over certainty extends all the way up to the mysterious realm of awareness itself. Consider creativity, that most human of qualities. When you have a sudden insight, when an artist conceives a masterpiece, when a scientist makes a breakthrough, where does that spark of originality come from? Perhaps it emerges from the quantum uncertainty bubbling away in the neural networks of the brain. The same principle that makes electrons dance around atomic nuclei might be what allows your mind to leap from one idea to another, to make connections that seem to come from nowhere. This connects to something even more intriguing, the question of free will. If the universe were completely deterministic, as classical physics once suggested, then every choice you make would be the inevitable result of prior causes stretching back to the beginning of time. You'd be like a sophisticated clockwork mechanism, following predetermined paths with no real agency. But quantum uncertainty introduces genuine randomness into the fabric of reality. Your neural processes, influenced by quantum events, might have access to truly unpredictable outcomes. Now, this doesn't mean your choices are random. That would hardly be free will either. Instead, it suggests that consciousness might exist in a delicate space between pure determinism and pure randomness. Quantum uncertainty provides the raw material of possibility, while your conscious mind somehow shapes and directs these possibilities into meaningful decisions. It's as if you're a conductor leading an orchestra where the musicians are quantum particles, creating harmony from uncertainty. The implications extend beyond individual consciousness to human society as a whole. Every innovation, every work of art, every leap forward in understanding might be rooted in quantum uncertainty. The Renaissance, the scientific revolution, the great philosophical traditions, all of these cultural flowerings might have emerged from the fundamental creativity built into the universe's quantum nature. But there's something even more beautiful here. Heisenberg's uncertainty principle suggests that complete knowledge, perfect prediction, absolute certainty are not just practically impossible, but fundamentally forbidden by the laws of nature. And perhaps that's exactly as it should be. A universe of complete predictability would be a universe without genuine surprise, without the possibility of growth, discovery, or wonder. The uncertainty principle ensures that reality always holds mysteries. No matter how sophisticated our instruments become, no matter how deep our understanding grows, there will always be aspects of existence that remain beautifully, tantalizingly unknown. This isn't a limitation of science, it's a feature of reality itself. The universe seems to have built-in protection against becoming boring. Think about your own life for a moment. The most meaningful experiences, the most profound moments of joy, love, discovery, they all contain elements of uncertainty. The thrill of not knowing what's around the corner, the excitement of possibility, the wonder of encountering something genuinely new. If you could predict every moment of your future with perfect accuracy, would life be as rich? Would love be as moving? Would beauty be as striking? Quantum uncertainty might be the universe's way of ensuring that existence remains an adventure rather than a predetermined script. It's as if reality itself values the journey over the destination, the question over the answer, the mystery over the solution. And here's perhaps the most remarkable thing of all. The uncertainty principle doesn't just govern the behavior of particles in laboratories. It governs the behavior of the particles that make up your brain, your heart, your entire body. Every breath you take, every heartbeat, every neural firing that creates your thoughts and feelings is touched by quantum uncertainty. You are not separate from this fundamental feature of reality, you are an expression of it. In a very real sense, you are the universe becoming aware of its own uncertainty. You are quantum mechanics experiencing itself subjectively. The same principles that govern the dance of electrons around atomic nuclei are at work in the dance of consciousness itself. The uncertainty that shapes the cosmos shapes you, and through you, the cosmos comes to know itself. This perspective transforms our relationship with uncertainty from something to be feared or eliminated into something to be embraced and celebrated. Uncertainty isn't a bug in the system of reality, it's a feature. It's what makes growth possible, what makes creativity flourish, what makes love meaningful, what makes the future an open book rather than a closed case. So, the next time you feel overwhelmed by the uncertainties in your life, remember that you're in excellent company. You're sharing that uncertainty with every atom in your body, every star in the sky, every particle in the vast cosmos. Uncertainty isn't a sign that something is wrong with the universe. But here's where things get truly fascinating, and perhaps a bit unsettling. If uncertainty is woven so deeply into the fabric of reality, what does that say about knowledge itself? What does it mean for our endless human quest to understand everything? You see, Heisenberg's uncertainty principle doesn't just place limits on what we can measure about particles. It whispers something profound about the nature of knowledge and our place in the universe. It suggests that complete knowledge, perfect understanding, total certainty, these aren't just practically difficult to achieve. They're impossible in principle. Think about it for a moment. We've spent centuries building better telescopes, more sensitive instruments, more powerful computers. We've mapped the human genome, photographed black holes, and sent robots to Mars. Each discovery feels like we're getting closer to some ultimate understanding, some final theory that will explain everything. But the uncertainty principle gently reminds us that even with perfect instruments and infinite time, there will always be things we cannot know simultaneously. This isn't a failure of science or technology. It's not something we'll eventually overcome with cleverer experiments or better equipment. It's built into the very structure of reality itself. The universe, it seems, has a kind of built-in privacy setting, a fundamental limit on how much information can be extracted from any quantum system. But rather than being disappointing, this limitation might actually be one of the most beautiful aspects of our reality. Because uncertainty doesn't just limit knowledge, it enables possibility. Without quantum uncertainty, electrons would spiral into atomic nuclei, stars wouldn't shine, and the delicate dance of chemistry that makes life possible would grind to a halt. The same principle that prevents us from knowing everything also ensures that something interesting happens. It's the cosmic equivalent of leaving room for surprise, for creativity, for the unexpected. A perfectly predictable universe would be a static one, frozen in predetermined patterns. Our uncertain universe is dynamic, alive, constantly creating new possibilities. Consider consciousness itself. Your thoughts, your dreams, your ability to contemplate these very words, all emerge from the complex interactions of billions of neurons. And those neurons, like everything else, are made of atoms governed by quantum mechanics. The uncertainty that clouds our understanding of individual particles somehow gives rise to the clarity of conscious experience. It's rather like the way a jazz musician needs space between the notes to create music. The silence, the uncertainty about what comes next. That's not an absence of music. It's what allows music to exist at all. Similarly, the uncertainty at the heart of physics isn't an absence of knowledge. It's what makes knowledge possible, what gives meaning to discovery, what ensures there's always something new to wonder about. This has profound implications for how we think about learning and discovery. If complete knowledge is impossible, then the goal of science isn't to eventually know everything. It's to participate in an ongoing conversation with reality, to dance with uncertainty rather than try to eliminate it. Every answer we find opens up new questions. Every solved mystery reveals deeper mysteries. The uncertainty principle also suggests something beautiful about the relationship between observer and observed. In quantum mechanics, the act of measurement doesn't just reveal properties, it helps create them. The universe isn't a collection of objects with predetermined properties waiting to be discovered. It's more like an ongoing collaboration between what exists and what observes, between the cosmos and consciousness. This means that when you look at a star, measure the temperature of your tea, or simply exist as a conscious being, you're not just passively receiving information about the world. You're participating in the ongoing creation of reality itself. Your observations, your measurements, your very presence helps bring the universe into focus, one uncertain moment at a time. And perhaps this is why uncertainty feels so fundamentally human. We live our lives not knowing exactly what will happen next, making decisions based on incomplete information, finding meaning in the space between certainty and chaos. The uncertainty principle suggests that this isn't a bug in our experience, it's a feature. We're not uncertain beings living in a certain universe. We're uncertain beings living in an uncertain universe, and that's what makes both possible. So the next time you find yourself frustrated by unanswered questions, by the limits of what you can know or control, remember that you're in good company. The universe itself is uncertain, and that uncertainty isn't something to be overcome, it's something to be embraced, explored, and ultimately celebrated. Because in a cosmos where everything was known, where every outcome was predetermined, where no mystery remained, there would be no room for wonder, no space for discovery, no possibility for growth. Now, as we reach the end of our journey together, we find ourselves standing at the edge of a profound truth. Everything we've explored about Heisenberg's uncertainty principle, from the quantum dance of particles to the limits of measurement, from the philosophical implications to the practical applications, brings us to one final beautiful realization. The universe isn't broken because we can't know everything. It's perfect precisely because we can't. Think about it for a moment. If we could know everything, if every mystery could be solved, every question answered, every particle pinned down with absolute precision, what would be left? Where would wonder go? Where would discovery live? Where would the spark of curiosity that drives human progress find its home? The uncertainty principle doesn't rob us of knowledge. It gifts us with something far more precious, the guarantee that there will always be more to discover, more to wonder about, more to explore. This isn't just philosophical poetry, it's deeply practical. The uncertainty that frustrated early physicists is the same uncertainty that makes chemistry possible. It's what allows electrons to tunnel through barriers, enabling the very computer chips that power our modern world. It's what makes the sun shine, fusing hydrogen into helium in a process that classical physics would have declared impossible. Without uncertainty, there would be no quantum mechanics, no modern electronics, no medical imaging technologies, no GPS systems, no internet, no way for us to have this conversation across space and time. The uncertainty principle teaches us that reality is not a clockwork mechanism, precise and predictable in every detail. Instead, it's more like a vast improvisation, a cosmic jazz session where the players know the general themes, but create the specific melodies as they go. Every measurement we make, every observation we conduct, every experiment we perform is part of this ongoing creative process. We're not just discovering the universe, we're participating in its unfolding. And here's perhaps the most beautiful part. This uncertainty extends beyond the quantum realm. It touches every aspect of our lives, our relationships, our dreams, our fears. We can't predict exactly how our lives will unfold, can't know with certainty what tomorrow will bring, can't measure precisely the depth of love or the weight of sorrow. But this isn't a flaw in the human experience. It's what makes life worth living. Consider how boring a completely predictable world would be if you knew exactly what everyone would say before they said it, exactly what would happen in every story before you read it, exactly how every sunset would look before you witnessed it. Where would the joy be? The uncertainty in our lives, like the uncertainty in quantum mechanics, isn't a problem to be solved. It's a gift to be cherished. This connects to something profound about consciousness itself. Some scientists speculate that consciousness might emerge from quantum processes in the brain, that our very awareness might be connected to the fundamental uncertainty of reality. If this is true, then our ability to think, to dream, to create, to love might all depend on the same principle that prevents us from knowing everything about a particle's position and momentum simultaneously. The uncertainty principle also reminds us of the importance of humility. For centuries, humans have dreamed of complete knowledge, of understanding everything about the universe and our place in it. But Heisenberg showed us that this dream is not just difficult to achieve, it's impossible in principle. There are fundamental limits to what we can know, built into the very fabric of reality itself. This might seem disappointing at first, but it's actually liberating. It frees us from the burden of having to understand everything, from the anxiety of incomplete knowledge. Instead, it invites us to embrace the mystery, to find peace in not knowing, to discover joy in the questions themselves rather than demanding immediate answers. The uncertainty principle also speaks to the deep interconnectedness of all things. In quantum mechanics, the act of observation changes what we observe. We can't step outside the universe to study it objectively. We're part of the very system we're trying to understand. This reminds us that we're not separate from the cosmos, not isolated observers looking in from the outside. We're threads in the fabric of reality, participants in the grand experiment of existence. This has profound implications for how we approach life. Just as quantum particles exist in states of possibility until observed, our own futures exist in clouds of potential until we make choices, take actions, engage with the world. We're not passive observers of our lives, we're active participants in creating them. The uncertainty in our future isn't a bug, it's a feature. It's what gives us agency, what makes our choices matter, what allows us to shape our own destiny. The principle also teaches us about the beauty of complementarity, position and momentum, wave and particle, order and chaos. These aren't contradictions to be resolved, but complementary aspects of a richer, more complex reality. In our own lives, we can embrace paradox rather than fighting it. We can be both strong and vulnerable, both certain and uncertain, both individual and connected to something larger than ourselves. As we contemplate the uncertainty principle, we're reminded that some of the most profound truths can't be grasped through pure logic or measurement alone. They require a different kind of understanding, one that embraces mystery, that finds beauty in the unknown, that discovers meaning in the questions rather than just the answers. The universe, it turns out, is far more interesting than we ever imagined. It's not a machine to be understood, but a mystery to be lived. Every electron that tunnels through a barrier, every photon that behaves like both wave and particle, every quantum measurement that reveals one property while hiding another, is part of an ongoing story that we're privileged to witness and participate in. So, as we conclude our gentle exploration of Heisenberg's uncertainty principle, we're left not with definitive answers, but with something far more valuable: a deeper appreciation for the mystery, a greater comfort with not knowing, and a profound sense of wonder at the beautiful, uncertain, endlessly creative universe we call home. The uncertainty principle doesn't tell us that we can't know anything. It tells us that we can't know everything. And in that limitation, in that fundamental humility built into the heart of physics itself, we find not despair but hope, not confusion but clarity, not an ending but a beginning. For in a universe where everything was known, where every mystery was solved, where every question had been answered, there would be no room for wonder, no space for discovery, no place for the beautiful, uncertain, gloriously unpredictable adventure we call life. And perhaps that's the most profound truth of all, that the universe's greatest gift to us isn't knowledge, but the eternal promise that there will always be more to discover, more to wonder about, more to love. In the end, we can never know everything, and that's exactly as it should be.